everybody, it's Mrs. Peachy from your WCA Earth Science class, and today I'm going to be doing a tutorial for you for the Unit 1, Lesson 5, Fossil Occurrence and the Age of Rocks portfolio. So I'm going to start here by going into the course tree, clicking on Lab Fossil Occurrence and the Age of Rocks, which I already have up actually, so we're going to kind of move the viewer over a little bit. And if you go to, it's page 3, you'll actually see that there's a link here for the Earth Science textbook, and we will be using this just primarily for information. So once I get to the Earth Science textbook, I want you to notice that we are not clicking on the pencil icon this time. Okay, I know we did that last time. But this time we are going to be utilizing the data table at the bottom of the screen, as well as the geologic timescale table on the second page, 357. And then you're going to be using your book to find some information, some definitions, as well as information on past environments, where different types of rocks are found, and carbon dating. Okay, so first off, let's go to my website, which you guys can access by clicking on the push pin icon at the top of your screen, and that will take you to my message boards. And in my message boards is a link to my website. When you get to my website, I would like you to click on the Earth Science B tab, and then the very first link that appears under Portfolio Tutorial Recordings is going to be this lab sheet, Fossil Occurrence in the Age of Rocks. Now you can either open this with Google Docs up here, and you'll have to make a copy of it in order to edit it, and then you don't need to save it because Google doesn't make you do that, which is kind of cool. Otherwise, probably the easiest thing and most familiar to you all would be to download it here as a Word document, and it will just open on your computer in Microsoft Word or in OpenOffice or whatever word processing program you happen to have. Okay, and that's right here. So the first thing it's going to ask you to do is to put your definition of an index fossil. So for this, I want to refer you back to the book somewhere. Yep, right here. Nope, that is not the book. We're just going to open it again because it always seems to get lost. All right, so you have a handy-dandy index in the upper left corner. If you click on that, and you want index fossil, so we're going to click under I for index, and you'll notice that it is on page 345. So if I click on that, it's going to take me to this section on index fossils, and it tells me that an index fossil is the fossil of an organism that was geographically widespread and abundant in the fossil record, but that existed for only a limited span of time. So what that's telling me is that an index fossil was found everywhere, lots of places anyways, and it was found for a very short period of time before it went extinct, which means to me that if I were locating, a rock strata somewhere, and I found this index fossil, that would be able to tell me approximately how old those rocks are. Okay? So I want you to write your definition of index fossil here. The second thing it tells you is materials. Well, I don't really use much for materials here. In your introduction, just explain the purpose of the lab. What is it you are trying to do? I'll have to read through it a little bit. Your hypothesis answers the following questions. How can the occurrence of fossils and their known age ranges be used to date rocks? Remember, it's a hypothesis, so you're going to kind of think about some of the stuff I just talked about a little bit, and then kind of come up with your idea of why you think or how you think that might be used. You might change your mind during the course of this investigation, which is totally fine and very normal. But, before you start, how do you think we might use these fossils to help figure out how old something is. Then there's some directions which I will allow you to read through, but pretty much I'm just going to explain them anyway. You are going to fill out this graph. This is just my version of how to do this graph. It's, I think, pretty easy. So let's go back to the data in the book. We gotta go back to, forget what page, the 54 maybe? No, 56? Yes. So I need the data table here at the bottom of the screen. And let's start with the first type of fossil, the foraminifera. If you notice, foraminifera first appears in the Silurian, and then, you know, the most recent occurrence is the Quaternary. So really what that's telling us is that there are still foraminifera today, okay? Because Quaternary is the period that we are in. So Silurian is the oldest occurrence, and Quaternary is youngest occurrence. So what I'm going to do is I'm going to highlight the boxes from Silurian to Quaternary, maybe. There we go. And then I'm just going to right click and change this color so that I'm filling in those boxes. So I'm going to color in the areas from the oldest occurrence to the youngest occurrence. And then you're going to do that for all the different fossil types, okay? So that's what you need to do at this point. So then kind of let me explain a little bit about what you can imagine you're actually doing. All right, so I wanted to explain a little bit about what you can kind of envision yourself doing here. So this first picture, I'm going to try to get my box. Here we go. Kind of showing you what we mean by rock strata. So there's different layers of rock, sedimentary rock, right? Because remember, sedimentary rocks have not been exposed to high heat and pressure. They haven't been melted, so they're pretty much preserved in whatever condition they were put down in. As you move downwards in the sedimentary rock record, you get to older and older stuff. So I always say, like, picture if I'm reading the newspaper every night and setting it next to my chair, and every night I put another newspaper on top of the old newspaper, the stuff at the bottom is going to be the oldest news, and the stuff at the top is the newest news, right? And if I grab one piece of one newspaper out, that represents a specific day. Now that newspaper may be made up of several pieces of paper because there's many different sections in the newspaper, but it still is representative of a single day. So as we look through here, you know, sediment is depositing all the time. And remember, these are specific types of locations like beaches, deserts, riverbeds, landslides sometimes can lay a whole bunch of sediment down all at once. So it's not necessarily every place where fossils are found, just particular areas and sometimes during specific types of events. Okay? So what we can look at is we can see that the fossils are embedded in sedimentary rock. So when we're looking at our example here from the book, right here, this is telling us specific types of fossils, and it's telling us the oldest place or oldest time period that those fossils have been known to be in, and the youngest time period they've been known to be in. Now, as you're completing this activity, you have to imagine that you're not excavating an entire column of rock. You're looking at just one small area. Maybe you're just looking at like this layer right here, or this little group of layers. That's representative of a single time period. That time period may be 1 million, 2 million, 5 million, 10 million years long, but it's not representative of all of time. So that's what you have to think of. You have to think of that you're actually sitting there digging up these fossils. They're all found in that particular area. That's why this question becomes important. Because one of these follow-up questions says, what is the age of the hypothetical rock layer that these fossils were collected from? So you have one rock layer you're collecting fossils from. What we want to know is, when was that rock layer deposited? So what you have to think about is that you're finding all these fossils. You're finding the foraminifera, the bryozoan, the gastropod, the brachiopod, the bivalves, a different type of gastropod, trilobites, ostracods, and another type of brachiopod. All those fossils are found in the same layer. So what that means is that the age of the rock that you're looking at has to be the period in which all those fossils occurred. You cannot be dealing with Ordovician age rock because foraminiferas weren't found in the Ordovician period, so that rock would be too old. There are going to be some that weren't found in the Quaternary Tertiary period, right? So you have to pick the age that is colored in all the boxes for question number 1. Question number 2 says, based on the age determined, do you think that the entire group of fossils could be considered index fossils? Why or why not? Remember, index fossils need to be found in a wide area, which we really don't know here because we're looking at one specific place. But they also need to be found during a very short period of time, like 1, 2, maybe 3 geologic periods. Right away, we can see foraminifera does not qualify as an index fossil, okay? So it's kind of a dumb question because really you're going to be looking at which ones of these would constitute index fossils would be the better definition. I don't like that question. Question 3 says, suppose that the particular trilobite listed in line 7 right here of the data table is limited to rocks of the lower Devonian, meaning the oldest part of the Devonian period, and they are widespread throughout North America. Can this be considered an index fossil? Well, we just talked about the definition, so I think you could probably come up with that conclusion on your own. Then it says this fossil is collected from an area of limestone and shale rocks. So what environment do we find limestone and shale? Your textbook does a pretty decent job explaining this. I don't remember where. Slow. QRS. Well, we're gonna try 344 and see. It says conditions for fossilization. I think we're close. Fossils and correlation. Here we go. Page 346 is where you're going to find out that information about which environment this rock was laid down in. You know, a lot of it's common sense. You think about sandstone, for example. Sand is found in deserts. It's found on beaches, primarily, right? The fossils can kind of further indicate that. If it's a lot of shells, a lot of sea creatures, probably the beach. If there's some snakes and, lizards and stuff, maybe some scorpion, probably the desert. So that's an easy enough one, but there are other types of rock that form in different environments. 56. The last question asks you about carbon dating and whether or not a leaf that was found with the gastropod in line 3 and line 6, if there was leaves within the shale, if that could be dated using carbon dating. I'm just going to tell you that yes, carbon dating does help to age things that were living at one time. But it is limited depending on how old the thing is. If it's too old, it doesn't work. Because carbon dating has a fairly short half-life, 5,730 years. So go and look in the textbook about that and what is the upper limit in age that you can use carbon dating, and then how old is this fossil. If it's older than the upper limit, then no, it wouldn't be a good use. If it's younger, then yes, it would be a good use. Okay? All right, we are out of time, guys, and that is the gist of it. So if you have any questions or concerns, feel free to give me a call at extension 2204 or send me a webmail message. Thank you.